In addition to the impact of the company's internal business areas, we cannot ignore the impact of the fourth industrial revolution in business relations. At the level of the supply chain, first of all, the relationship between suppliers and customers should be mapped out. Welcome to a new video where we're going to continue talking about the fourth industrial revolution and the Internet of Things. Reading a paper, getting some information now, and starting some open forum discussions. Industry 4.0 organizes suppliers, manufacturers, and customers in a virtual, vertically, and horizontally integrated value chain. So that's why it is important. The offline dimensions of service and e-customer satisfaction could be indirectly linked via website quality and related issues. Overall, the significant amount of data generated through digitalization or digitization, better said, affects all areas of the company's business, thus improving transparency, integration, and designability, and providing such more information on customer needs and the individual tasks needed to fulfill them. Industry 4.0 also creates completely new value creating business areas. For example, product design and development and data security will become much more important in the future. The tools of Industry 4.0 in the corporate value chain are summarized, and it can be seen that the effects of most of the technologies span over functional boundaries and affect the entire value creating process or the company itself. Overall, accessing real-time data at different points also has a positive effect on strategy, finance, and process design. Data generated in each area is also available to other areas and provides information transparency. These tools contribute to system-based and process-oriented thinking and the integration of processes within the organization. And then beyond organizational boundaries. Technologies help to increase the agility, adaptability, and alignment of companies cooperating in a network of value chain in order to gain competitive advantage. So in order to gain that competitive advantage, we're capable of evolution and evolution through machines. So not only within ourselves as humans, but also outside of our own species. We try to replicate ourselves in the machines. So the involvement of companies in the fourth industrial revolution remains, for the time being, a question of decision making. The use and development of new unknown technologies is a risky activity and is currently expensive, although it promises considerable savings, thus increasing revenue for those who make the decision early. And that's the thing, we are on a race. We are on a race of digitization. And that's why we've been having industrial revolutions in the past. Everyone can be noticing that it might be a risk. Every investment has a risk. But in order to be the first one, people are willing to take that risk to make some advances, even though they don't know what the result of those are going to be. And would you be willing to risk in industrial revolution? Would you be willing to risk on any technological advancement? Will you be willing to be the third, actually thinking of being the first? And that is something that has been going on because everyone says like, yeah, if I do this, then I will take this as a solution for my business and it will just acquire such a speed, agility, and of course a shortcut to my supply chain. That's what we all want on the industries, right? Well, what do we want in there? In some industries, progress, development, and rapid development of applications cannot be avoided in order to stay competitive. However, there are also some industries that will only embark on such developments if others have already marked out the path and the technology required is affordable for sectors operating with smaller profit margins. At enterprise level, the introduction and maximization of the impact of Industry 4.0 is dependent on the creation and consistent implementation of a corporate digital strategy. Some factors may hold back or obstruct the spread of this revolution or this Industry 4.0. But we also have some studies that have been happening. For example, in 2016, PwC produced a Global Industry 4.0 survey in which 2,000 experts from 26 countries were asked about how their companies will exploit the opportunities offered by digitization. The majority of the companies surveyed, 52%, and that equals to the thing that they said. And that is that the biggest obstacle to the implementation of Industry 4.0 is the lack of a clear digital strategy in value creating processes and of support for corporate executive for the introduction of digital technology. What kind of support? What kind of support can you be having in your mind when you first hear about this? And by the way, the lack of clear digital strategy and value creating. So, what am I going to gain if I invest of this? And we're not talking about small quantities. When we want to be first, when we want to be on the loop of new and technologies, it's going to be pricey. So, even if it is something like we're going to map out, what are we talking about? So, it's quite interesting because it's still a risk. And sometimes when we see like a new and high technological device out there, we are not seeing like the processes behind and even the final product, it's a risk itself. So we're constantly taking the chances on things that are like 100% proven, 100% just with all the things right on track and with all the outcomes mapped. Everything is still ongoing. Everything is still a process, especially with technology. It's like we will never know all the outcomes of it. But we also have Porter and Havelman that they argue that the company should not address fundamental issues superficially and ignore industry signals. The digital services connected to the product must be those for which the buyer is willing to pay. The fact that certain data is available does not mean it is marketable. It is therefore necessary to think carefully about what creates value for the buyer. And we're mapping here sales and marketing. So we can also translate these to products and services. Just because something is available doesn't mean that it's valuable for us, for you, or for me. And that's also a risk. Data security has been mentioned several times. This is a critical point for development. Control of access must be ensured, and must the security of networks, devices, sensors, and others, and the proper encryptation of information. New entrants can also appear with the smart products with market-related services to implement and innovate a new type of customer-centric business model and possibly extend the boundaries of the industry. The big question is when to take the plunge. If your company waits too long, your competitors or new entrants can tailor the market and gain an advantage in the learning process. The production of smart products requires a new kind of technology, capabilities, and processes throughout the value chain. And you also have the risk that if you go in a later time, you also will be buying to other of your competitors those new advances because you just came out late and you can no longer reach the primary source of that information or service or product. Now there's a lot of third people selling you the same, so that's another thing. But what about also that the company has to realistically see what capabilities it can develop and of course what it needs in order to be involved with external partner. But the initial basis for industrial digitization, but this time is actually digitalization, is the networking of devices. This is commonly known as the Internet of Things, a concept which the profession cannot define with anonymous agreement. The main idea behind the IoT, that means the Internet of Things, is that over the last few decades, IT and telecommunications have evolved, as we were mentioning at the beginning. The aim is to build long term and accurate observations using complex analytical methods to create better planning, operational optimization, and maintenance solutions than before. We are on the verge of a digital industrial revolution that will lead to a vertical, intracorporate, and horizontal intermarket interconnection of sensors, machines, workpieces, and IT systems across the entire supply and value chain. IoT tools are the technological components that enable a product of production machine to connect to a corporate network and to collect and or share data. These may include the previously mentioned sensors and others. But when we use IoT tools in corporate processes and we begin collecting data, we have several options to utilize them. Large amounts of data which are unmanageable in continuous and conventional data analysis systems are called big data. Collecting them and sharing them with authorized individuals or organizations can be done through enterprise data warehouses or clouds, possibly with cloud computing companies. So much data is only really valuable if we have a tool to analyze it and when to put it and then actually translate it into a user friendly form. This is big data analytics, which can be a sort of competitive advantage. In order to obtain the right data and information, companies spend more and more on developing data mining softwares, algorithms, and enterprise resource planning or ERP interfaces, which not only represents a problem on the investment side but also in terms of finding the right workforce. CPS connects physical devices with cyberspace. CPS uses sensors, 3D scanners, camera, or radio frequency identification, also known as RFID devices, and provides mass data for the process. This is actually the realization of the IoT. The CPS solution used specifically in production, the Cyber Physical Production System, CPPS, is a possible networked system of production equipment, workers, or products in the production process. This makes it possible to make the production process more flexible and improve its efficiency, and to tailor make products with mass production methods. Future production systems need to be developed considering the need for strong product individualization and therefore the need for highly flexible production processes. To accomplish this challenge, CPPs should be integrated into production sites in order to create smart factories. A CPS is central to the vision and should be incorporated with the smart machines. storage systems, and production facilities capable of exchanging information with autonomy and intelligence. These CPS monitor the physical processes, make decentralized decisions, and trigger actions, communicating and cooperating with each other and with humans in real time. This facilitates fundamental improvements to the industrial processes involved in manufacturing, engineering, material use, supply chains, and life cycle management. But what about smart products? These can signal the current state of production or the process supervision, the process characteristics, and the future need for maintenance, and make suggestions about the nature of the intervention or even intervene themselves. With the spread of robots and artificial intelligence, less and less monotonous work is needed, and people can debate on this. These tasks are performed currently by machines with significantly lower financial costs after they make a big investments in the industrial sector. Smart devices such as self-propelled vehicles and robot arms have also appeared in corporate practice, where they serve the physical supply requirements of production and logistics processes. Smart devices also connect to the network, interacting with their environment and with the ability to react to changes and to track different data alongside the environment, alongside our bodies, and others. And with the ability to react to those and also to react to changes and even make decisions therefore and give you like an analysis of those as well. The implementation of robots is a relevant option in unique production systems, as an intelligent system is capable of identifying problems even at a source of failures, and therefore this allows the firm to delay and increase the precision of the operation. For the implementation of Industry 4.0, tools that generate data and create big data are essential, including sensors, RFID chips, 3D scanners, cameras, and robots. And some of these are actually even nowadays created in a home-based mode or model. So this is actually also something to take into consideration. Machines and people use interfaces to communicate, most often in a real-time way. Additional tools such as clouds, local data warehouses, and ERP system collect, store, and distribute data. There must be platforms that provide a common base for all these machines and devices, and the most up-to-date standards and most frequently in-house developed software to extract the relevant information from the generated data in a way which is accessible for and convenient for users. The device itself, which displays the interface, does not need to be specialized. It may be a worker's mobile phone. The essential point is that it is easy to visualize the information needed and is easy to be used. All of this is particularly exciting because it is attainable at low cost, and a smartphone which sits in most people's pocket can become a connection and control tool. In day-to-day operations, all the forms to be filled in and other automated forms of communications can be used, besides emails and telephone calls, which can help when standard forms of communication are insufficient to support the exchange of services. Integration is created by the internet network connection and the real-time interconnection of all the things mentioned above. So we have machine and human that in order for both or one of them to function, they need to coexist. And one of them, that will be technology. Because if technology doesn't have data on the outside, or people putting data directly on the machine, they wouldn't have something to process. So it is something that it is interconnected with us, even though we don't want it. So we have the example of the smartphone. Even for the phone to read the weather, they need to collect data from the environment, and someone is submitted that data to the cloud, to a website, or to whatever. So we're replicating something that it will need us in order to function, or it at this moment it needs us to collect information on a basic mode home model as we were explaining right now. So it is something really interesting in that point. But let me know, what do you think about this? Do you think that this real-time interconnection might be a flaw that will we be paying off in the future, or do you think that it is something that is necessary in order to continue developing more technological advances? That is where to have this interconnection right now and not to escalate it to something else. Let me know. But the presence of the tools, methods, and procedures listed above in a company is necessary to for it get started on the development path generated by the fourth industrial revolution. So if someone wants to be on that road, they just need to have those requirements. But on the next video, I'm going to tell you the steps of it. So thank you so much for being here. It's been a pleasure. I hope you're having a great day. And of course, we're going to encounter again on the next video. Bye bye.